So good morning students. The today concept is viability of the seeds. Yes, which one? Viability of the seeds. What is this viability of the seeds? So in previous classes we studied about the viability of the pollen grains. Right now, similarly here the viability of the seed. Right? The ability of the seed to retain the power of germination over a period of time, that is called viability of the seeds. What is viability of the seeds? The ability of the seed to retain the power of germination over a period of time, that is called the viability of the seeds. But this viability of the seeds varies greatly. Right now, in few species, the seeds lose viability within few days to few months. Right now, in some seeds, they lose viability within few months to few months. Right now. But the seeds of the large number of the species live, right ma? So several years. So there are several records of very old yet viable seeds. There are, right ma? So there are several records of very old yet viable seeds. Sir, which is the oldest? Which one ma? The oldest is that of lupine. What is that? Lupine. The oldest is that of lupine. Sir, what is this? What is the scientific name of this lupine? Lupine arcticus. Yes, this is the lupine arcticus. Right now, sorry, scientific name now we can write like this, or else lupine arcticus. Lupine arcticus. So this lupine arcticus is the oldest right now. So excavated from Arctic region or Arctic tundra. So it is excavated from Arctic tundra. So lupine arcticus is the oldest seed. It is excavated from Arctic tundra. Right now, the seed germinated and flowered. The seed is germinated and flowered after the estimated records of 10,000 years old seed. How many years, ma? 10,000 years old seed. How many years? 10,000 years old seed. Right now. So a recent record of 2000 years old seed, a recent record of 2000 years old viable seed, that is a phoenix date palm. What is that seed, ma? Date palm seed. Phoenix dactylifera. Which one? So Phoenix dactylifera. Phoenix dactylifera. Right now, discovered during the archaeological excavation at King Harold near Dead Sea. The place is near Dead Sea. So the recent, right ma? See. A recent record of 2000 years old viable seed is that of date palm. Right now, what is the scientific name of that date palm? So Phoenix dactylifera. Which one? Phoenix dactylifera. So it is discovered during the archaeological excavations at King Harold, the place near Dead Sea. The place near Dead Sea. So this right now. But the seed viability is influenced by the conditions during the storage. Right ma? Storage and non-germination. Right now, during storage and non-germination. So the loss of viability is generally due to different things. What are those different things? One is right now exhaustion of the food around the embryo. Why seeds are going to lose viability? There are different reasons. The first one is which one? Excavation of food, exhaustion of the food around the embryo. That is one reason. And what about second reason? Damage to embryo. When the embryo is damaged, so that it is unable to germinate. Right? So these are right, man. So this is about the viability of the seeds. This is about viability of seed. Yes. The next concept is polyembryony. Polyembryony. What is the next concept, ma? The next concept is polyembryony. So what is this polyembryony? Polyembryony has been defined as the occurrence of more than one proembryo or embryos in the developing ovule into seed, that is called polyembryony. What is polyembryony, ma? So polyembryony has been defined as the occurrence of more than one proembryos or embryos developing in the ovules into seed, that is called polyembryony. That is called polyembryony. But this polyembryony was first time observed by Antony von Leeuwenhoek in orchid seeds. Where, ma? In orange seeds, not orchids, in orange seeds. The polyembryony was the first time observed by Antony von Leeuwenhoek in orange seeds. But the polyembryony in angiosperms may arise by different methods. The first one is cleavage of proembryo. Which one, ma? Cleavage of proembryo. Example for that, orchids. Cleavage of proembryo. Example for that, orchids. And the next one is formation of embryo by cells of the embryo sac other than egg. What is the next case? The formation of embryo, right now, by the cells of embryo sac other than egg. Right now we know that if we take the embryo sac, right now, so this is an embryo sac. In embryo sac, this is egg and the central cell. So formation of embryo other than the formation of embryo by the cells of embryo sac other than egg. See, the embryos are formed other than egg, not from the egg. Right now, so example for that, orzymome. Second one, example for that, orzymome. Right now, and the third one. So what is the third possibility? Activation of some sporophytic cells. Which one, ma? Activation of some sporophytic cells of the ovule. Adventative embryo developed from nucellus cells and integuments. Nucellus cells and integuments. Example for this, citrus and mango. The third one. Example for this, which one, ma? Citrus. In citrus and mango, right now, so how the embryos are formed? Sporophytic cells. Right now, sporophytic cells of the ovule, adventitious embryo developed from nucellus and integuments. We know if we take the structure of ovule, where integuments are present and where, right now, so nucellus is present in a ovule. Right now, so if the embryos are developed from sporophytic cell, right now, so that means 2n, nucellus is 2n and integuments. Right now, so if those from these two things if the embryo is developed, right ma? So in which members we can find out the development of embryo? From integument and unicellular in the members of citrus and mango. So this is about polyembryo. This is about polyembryony. This is about which one ma? Polyembryony.